Okay, so pi over 6, do you remember how many radian, or how many degrees that is? It is 30 degrees. How about pi over 4? 45 degrees. Pi over 3? 60 degrees. Okay, thank you. And pi over 2? 90 degrees. Sure, we will. Yep, great. So what you need to be able to do, and this is probably the most important part of trigonometry, is and its application to calculus, is to be able to come up with the terminal point that sits right there. Okay, so if this is a 30-degree angle, we say that in the unit circle the radius is always 1. So what are the other sides? 1/2 and root 3 over 2. Good. So you've come up with those. So that means that this coordinate right there is root of 3 over 2 and 1/2. That's what we call the terminal point. We all good with that? So for the next one, instead of drawing a 30-degree angle, I draw 45. And we know that the radius is always 1. Does anybody remember what the other sides are? Good. Root of 2 over 2 and root of 2 over 2. See how much you remember? So that means that this coordinate is root of 2 over 2 and root of 2 over 2. As I draw the 60-degree angle, which one is that similar to? Yeah, what is this side down here? 1/2 is now on the bottom. That's the smaller one. And the larger one is the root of 3 over 2. So what then is the coordinate? 1/2 root of 3 over 2. Yep. So, and that's something that you'll recognize, is that as you do something a second time and a third time, it'll be easier. But yeah, we took like a whole week to talk about this and explain this before. I didn't either while we were doing it. Yeah, I didn't either. 90 degrees is right here. Okay, can somebody tell me this terminal point right there? 0, 1. Yep. So I'm not going to do all of these, but I'll do a couple. So we'll let Laura pick one. Laura, A, B, or C, or D. Which one would you like to do? She would like to do B. So negative 5 pi over 4. 5 pi over 4 is how many degrees? 225 degrees is correct. So I'll just show you how you make that computation in case you don't know. In order to convert from radians to degrees, we multiply by 180 and we divide by pi. Notice what happens. Pi's cancel, and you get 180 divided by 4 is 45. So it's 5 of those 45-degree angles, which is 225 degrees. So you have negative 225. Let's check out negative 225. Which quadrant would that place me in? It places me in the second quadrant. Because it's negative, it rotates that way. And we don't need to do a lot at that point. You just recognize which one of these is it most like. The 30, the 60, the 45, or the 90. It's like the 45. So you have root of 2 over 2. Root of 2 over 2 is it could be positive or negative. Which one? The x value, because it's in the second quadrant. That kind of bring back a little bit of memory to you? So if you flip it over, do you think you'd be able to fill out the unit circle? Okay. So, and folks, by the way, I threw this together last year, and this is what my calc class started doing when I had COVID last year. And so when I got back, they said, we still don't really remember anything about trig. And remember, when they had their trig, it was during 2020 when we were doing half days. So that was a little bit different for them. So you guys seem to have a pretty strong basis for this. So I'm just asking, do we need to go through the whole unit circle? So you kind of get those so could you determine a terminal point then if you had to? Could you come up with like the root of 3 over 2 and 1/2? That is the most important element that you'll need to know for this class moving forward. And so if you can do that, you're doing just fine. We all good? Okay, let's look at a couple other things then that are going to be important as well. So we'll move on from there. Let's talk about the sine and the cosine and the tangent of these things. Okay, so pi over 6, how many degrees? 30 degrees. So I'm right there. And so we've learned now that we can determine that terminal point pretty quickly. What is it? Root of 3 over 2 and 1/2. Good. So the question then in this situation is, what would the sine of pi over 6 be? Well, sine, do you remember which value sine is? It's the y value. So the sine of pi over 6 or 30 degrees is 1/2. Do you remember which one cosine is? Yeah, so cosine is the root of 3 over 2. Do you remember how we determined tangent? Yeah, tangent is 1/2 divided by the root of 3 over 2. So instead of multiplying, or instead of dividing by the root of 3 over 2, I will multiply by the reciprocal. And what do you notice happens? And I get 1 over the root of 3. Can I leave it like that? What does it become? Thank you. Nice job, you guys. So, and I mean, I'm not saying that facetiously. I put this together last year with the intent of going over it. I will tell you one thing I've learned. Being in school really, really does matter. That the recall from last year, I feel bad for those kids. And by the way, as I said before, that was my highest performing group on the AP exam I've ever had last year. So hats off to them. But they did trig at a distance, and that was more challenging. And they did a good job while they were with it, but the recall was tough. Your guys' recall right now is pretty good. So pi over 4, let's flip it over. I don't want to do pi over 4. We're going to do a different one. Let's do 3 pi over 4, okay? Let's do 3 pi over 4. How many degrees is 3 pi over 4? Anybody know? Yeah, so let's talk about how people came up with that so quickly. They recognize it's a 45-degree angle, right? And so 2 of the 45s would be 90. 3 of the 45s would be 135. So we already know that it's a 135-degree angle. And so it's going to make that 45, 45, 90 special right triangle. And what is this coordinate going to be then? Negative root of 2 over 2. Root of 2 over 2. And so the sine value will be, cosine will be negative root of 2 over 2, and tangent will be negative 1. So looks like you're able to determine not only the terminal points and the knowledge of the unit circle, but you know the sine, cosine, and tangent values too, don't you? You really did learn a lot last year. I know you don't necessarily remember a lot, but when I ask you to recall, it's a lot of it's really there. I want to look at some important values here that we could take in, and namely sine, cosine, and tangent of 0. We're not going to worry about those because they just don't really come up that much. But these are really, really important. I can't tell you enough to try to focus and memorize these values. So I'm gonna try to do a demonstration here with my arm so you can see. But if we have an angle of 0 degrees, sine is the y value. So what is the sine of 0? 0. Pi over 2 is 90. So what is the sine of 90? 1. Again, it's the y value. So the sine of 180 is 0. The sine of 3 pi over 2 is negative 1. And then we get all the way back around to 2 pi, it's 0. So those will come up a lot. So just like the root of 3 over 2 and 1/2, root of 3 over 3, these are values that come up a lot as well. Let's do the cosine now. Cosine of 0 is 1. The cosine of 90 is 0. Cosine of 180, negative 1. 3 pi over 2, 0. and back to 2 pi will be 1. Now remember, there's two ways to think about tangent. Tangent is your y value divided by your x value. I also like to think of tangent as being y over x, or rise over run, which is just your slope, isn't it? So what's the slope here? 0. What's the slope here? Undefined. What's the slope here? 0. What's the slope here? Undefined. And 0. So coming up with those values definitely comes up from time to time. We okay with that? Nice job. Flip it over. Okay, Ava, why don't you pick one of these, 14 through 22.
I don't know.
Just pick one.
15.
Great, we're going to do 15. Cosine of 11 pi over 6. So that would be kind of putting it all together, being able to come up with this piece. 11 pi over 6. What is pi over 6? 30 degrees. So what's 11 of those? 330. So we're looking at 330 degrees. So I have 330 degree mark right over there. So that's 30 degrees right down there. So what would this terminal point be? Root of 3 over 2 and negative 1/2. So if I ask for the cosine of 11 pi over 6, what is it? It's the root of 3 over 2. Good. Patty, pick one. Patty wants to do 21, the tangent of pi over 3. Pi over 3 is how many degrees? 60, what? So I draw the 60-degree angle, okay? What's that going to be? 1/2, root of 3 over 2, good, you've got those. And then how do I determine the tangent? Y divided by x. Okay, so root of 3 over 2 divided by 1/2. And so I multiply by 2 over 1, and I get the root of 3. Cosine is the x, sine is the y. Yep. Okay, I need a fist of 5. 5 is like Mr. Gens. Like if I had to do a worksheet on that, I'm pretty confident I can do the whole thing. 1, I don't feel like we ever covered this. Where are you at? Show me. I need numbers. Okay, good. So you're definitely all at a point where if you needed some review, we could talk together. And just to be clear, if you do have a question in class when we go over it and it's applied, let me know and we could talk about it again. For example, suppose Jay is like, Mr. Gens, why is the cosine of 0, 1? I need to see that again. I'm like, okay, I'll show you. But I just don't want to be drawing any blanks, okay? We all good? Another thing that would be helpful is if you understood the graphs of sine and cosine. So we graph sine, cosine, tangent, cotangent, secant, cosecant. You should know the graph of sine and cosine. Sine has a period of how far? 2 pi. We divide it in half to get pi. We divide that half to get pi over 2. So you may know why we divide it into 4 parts. The 4 quadrants it takes to repeat itself. Very good. So in this situation, what we want to do is we want to draw the graph of sine. Do you remember the maximum value that sine achieves? The maximum value of sine is 1. What's the minimum value? Negative 1. And so, do you remember if sine starts at the top, bottom, or middle? It starts at the middle. Okay, so let's come back because math should never be about memorizing stuff, should it? It should always be about understanding why. And so let's go back to that question right there. Why does 1 start at the top? Why does 1 start at the bottom? And it has everything to do with what we just filled out. we are putting these spots on the graph. See that? So we're taking the unit circle and we're just shoving it right onto the graph. That's all we're doing. So notice how sine starts at 0, whereas cosine starts at 1. This is why. Okay? And so that's how I always kind of work through it in my mind. So sine is going to start at 0, and then from there it goes up. Because at 90, the sine value is 1. Then at 180, it's 0. And then at 3 pi over 2, it drops down to -1, and then there. And we can make a nice little sine wave, can't we? Okay, on that same graph, in order to save time, I'll draw the cosine graph. How is cosine different? It starts at 1, and we just discussed why. Okay, starts up there, and then it drops. So you can maybe dash it if you would like to. Again, I'm just trying to save you time. I know Tim doesn't like to draw these out. So the sine and cosine graphs are actually the same. It's just that they have a horizontal shift that's slightly different. Agreed? It's just a horizontal shift that separates them. That's it. So let's skip 25 and let's go, or should we try 25? Okay, we'll do 25 here. Okay. So as I look at this, what is the amplitude? It goes all the way up to 3. What is the period? 1. The period is always 2 pi divided by your b value. And since it's 2 pi divided by 2 pi, it will be 1. So the period is always 2 pi, but if we see a number there, we divide it by whatever number is sitting there. Okay, that's how we calculated the period last year. So we're going to mark off 1, divide it in half to get a half, divide it in half to get a fourth, and then 3/4. Notice it goes up to 3 and down to -3. Where will you start? You do start at 0. How come? Because it's a sine graph. When would I go down instead of up? If it was a negative. We good? So we'll do 26. We'll move on from there. And by the way, I do not have an assignment for you for this. This is the assignment that we do it together in class. Tomorrow you'll have the assignment. The amplitude here is always positive. Amplitude is always positive. Absolute value of the number in front. And then the period, who knows the period here? What's that, Trey? How do you come up with 4 pi? There's not a 4 up there. Oh, Trey does 2 pi divided by 1/2. He multiplies by the reciprocal and he gets 4 pi. So to save time, let's not mark out all these. Let's just let's just make the marks. We won't label them. I think you know what they are: 1 pi, 2 pi, and 3 pi. Yep. You take 2 pi and divide it by the number in front of x. And the number in front of x is 1/2. Okay, now I'm going to mark 1 and -1. Where does this one start? It starts at the bottom because it's negative. And then it heads up. So hopefully you can appreciate that all the work we did last year, that is sticking to your brain to some degree. Your sine and cosine graphs, most of you guys got about 100% on that test. You did very well. Good job. We flip over. Okay. So another thing that is going to be very important to your ability to move forward in this class is to remember some of your trig identities. The first trig identity is the most important trig identity, which is sine squared of theta plus cosine squared of theta is equal to 1. Please don't ever forget that. Okay. That's an absolute must. The second Pythagorean identity is 1 plus tangent squared of theta is equal to secant squared of theta. Those two are used all the time. This one is not used as much. 1 plus cotangent squared of theta is equal to cosecant squared of theta. What I will expect of you is come time for the test, I expect that you know how to find terminal points. Can you do that? Yeah. I also expect that you would be able to graph sine or cosine. I'm not saying tangent or cotangent or secant or cosecant. Just those two. Are you okay there? You have to have this memorized. You have to have this memorized. You don't need that one. Okay? I won't put that one on the test. But the first two are fair game. Anytime. Here's the other one that's fair game. This one does come up. Okay? The double angle formula. Sine of a double angle is equal to 2 times sine of a single angle times cosine of a single angle. This one you have to remember for the test. You do not need to remember the cosine of the double angles. And I'll just write it here. Cosine of a double angle, we actually have 3 different formulas that could be used. One is cosine squared of theta minus sine squared of theta. Another one that's used is 2 cosine squared of theta minus 1. And another one that's used is 1 minus sine squared, or 2 sine squared of theta. You do not have to remember the cosine double angle formulas. You do need to remember the sine double angle, the Pythagorean 1 and the Pythagorean 2. Okay? Just want to be transparent. Well, good. If there's one of these I'm going to use on the test, which one do you think I'm most likely to use? Without a doubt, this is the absolute must knowledge piece. Okay? All right. Even in odd identities, this is something that can be useful. Remember, if you have sine of a negative angle, remember what happens to the negative? It goes on the outside. Do you remember for cosine of a negative angle? It disappears. Remember tangent of a negative angle. It goes on the outside. And the same would work for their reciprocals. So the reciprocal of sine is cosecant. The reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. So those fall through for their reciprocals as well. Since you guys are making connections right now, and when you make connections, you actually build neurons in your brain. You actually get smarter. We're going to help you make another connection so you can get smarter. Does anybody not want to get smarter today? Okay? All right. So everybody's wondering why that goes away, right? Okay, I'm going to show you why, and it's going to be very simple to you. All we need to do is look at this. Is the red graph sine or cosine? So let's look at the cosine graph. Notice if you go cosine of a positive, you get a spot here. If you go cosine of a negative, you get the same spot there. Cosine of a positive, spot there. Cosine of a negative, spot there. Doesn't matter whether you go positive or negative, you get to the same height, don't you? Whereas for sine, if you go over here, that's your y value. Whereas if you go back, that's your y value. Notice how it's exactly opposite? So that's why you get the negative. So it has everything to do with an even graph, which means it's symmetrical on the y-axis. Sine is symmetrical about the origin, so it's symmetrical 180. And that's why we get those even and odd pieces. So it has everything to do with that graphical piece. Okay, good job. So let's simplify some of these things. Secant times tangent times cosine. Okay, so good. So there's a couple ways to look at this. I started to see people think about it. Okay, 1 over cosine of x times, tangent is sine of x over cosine of x, and cosine is cosine of x over 1. So what's going to happen? Just one of the cosines canceled, right? And you're left with, which is just tangent. So from the beginning, you could notice that secant and cosine are reciprocals, so they will cancel. You look at the next one, we have sine squared of x over 1 times what? What's cotangent? Cosine of x over sine of x. And what's cosecant? 1 over sine of x. Good. What's going to happen? The sines will cancel all of them, and you'll be left with. Good. Good job. Is that kind of, remember a little bit of that? Okay, let's flip it over and see what we have here. 1 minus cosine squared. What is 1 minus cosine squared? Oh, we have to remember this. Why?
Sine squared, cosine squared is 1, subtract cosine squared.
Good. So Patty is using this piece. Sine squared plus cosine squared, I'll put an x there, is equal to 1. So notice if you subtract the cosine squared over, this is what you get, right? And you would get sine squared on top. So sine squared of t over sine squared of t is going to give you 1. What is 1 minus secant squared? Negative tangent squared. Remember, it's 1 plus tangent squared of x is equal to secant squared of x, right? So if you subtract the 1 over, it'd be secant squared minus 1. But this is 1 minus secant squared. So it's not positive tangent squared, it's negative tangent squared. Everybody see that? So good, you have tangent squared of x over negative tangent squared of x. We get negative 1. Okay, for 33, most people would like to just distribute right away, wouldn't they? Let's not distribute. What is cosecant squared minus 1? Good. Cotangent squared. So Kaylee is using this one right now. She's saying that 1 plus cotangent squared of x is equal to cosecant squared of x. And notice how when she subtracts the 1, she gets cotangent squared. What's the relationship between tangent and cotangent? So when you multiply them, you'll get 1. What do you want to do for 34? Good. Sine squared on the bottom. So what's cosine squared over sine squared? Cotangent squared. Good. What's secant squared minus 1? Tangent squared over tangent, which is going to give you tangent of x. You try 36 on your own. Best of luck tonight to all those in action, especially girls soccer, as you have your last home game. Hope it is amazing. Boys, where are we playing? Nobody knows. Swim and dive? Thursday night? Okay. Volleyball?
We had our game last night.
How'd it go?
Well, we played Northfield, and they had 2 D1 starters.
Okay.
So we got creamed.
All right.
It did not go good.
Sorry about that.
Okay.
We have cross country in action on Thursday at Owatonna. Test match today against? Is this sections?
Yeah.
I saw a student earlier who was in tennis, and they were not playing tonight, so I forgot about that one. All right, cosine squared minus 1 is?
Oh, yeah.
Negative sine squared on top, negative cosine squared on the bottom. That is a tangent squared of x. So, as you look at the rest of this, this is for your benefit, okay? So, I took a class period to review some trig with you. I don't plan on reviewing any more trig after this. Tomorrow we get into the calculus of trigonometry, okay? Now, here's what I leave you with. Here's the unit circle all displayed out for you, but I trust you would be able to make that on your own anyway. We wrote down the even and odd identities, didn't we? We also wrote down the Pythagorean identities, didn't we? In case you want even more, you can see on the next sheet, I have all of the formulas that we use throughout trigonometry. And this sheet was very helpful to some people. They really liked these trigonometric identities in their shape and form. So that's what I could provide for you. You can keep that as part of your notes. What am I finding out for people that go off to college? They think that things like this are helpful. Okay, so they are downloading them from my website. They're sending me emails. Could you send that to me? Or they're saying, hey, Mr. Gens, rewatch that video because I forgot all of my trig. So you have the rest of the hour to work. If you have a question, I'd be happy to help you with your question.